Hello, welcome to today's lesson on calculating specific latent heat. We will begin by learning how the energy required to change the state of a substance, E, is calculated mathematically by multiplying its mass, m, by the relevant specific latent heat, L. We will then define the variables used in this equation and their units. Finally, we will work through a detailed example of applying this equation. So far, we looked at latent heat. This has given us an understanding of the energy required for substances to change states without changing temperature. Building on this foundation, we can now introduce the equation E is equal to ml to quantify the energy involved in state changes. This lesson will enhance our broader understanding of how energy is transferred during phase changes and the specific conditions under which these transformations occur. Let's get started! Firstly, let's clearly understand what the formula E equals ml means. This equation helps us calculate the energy required to change the state of a substance without changing its temperature. The formula is energy required equals mass multiplied by specific latent heat. We have two main variables to consider in this formula. One is mass, which represents the amount of the substance we are interested in. Mass is measured in kilograms. The other is specific latent heat, which, as we have learnt, is the amount of heat energy needed to change the state of 1 kilogram of a substance. The unit for specific latent heat is joules per kilogram. The energy required to change the state of a substance is measured in joules. Thus, by multiplying the mass in kilograms by the specific latent heat in joules per kilogram, we get the required energy in joules. It's crucial to ensure these variables are in the correct units before performing any calculations. To solidify our understanding, let's go through a worked example. Imagine you have a block of ice weighing 2 kilograms, and you want to determine the energy needed to melt this ice. Given the specific latent heat of fusion of ice is 334,000 joules per kilogram, we can follow these steps. We begin by identifying the given quantities. The mass of the block is 2 kilograms, and the specific latent heat of fusion is 334,000 joules per kilogram. Next, identify what you want to find out, which is the energy required to melt the ice. Since we are going from solid to liquid, we use the specific latent heat of fusion. Now choose the relevant formula. Since we are given the mass and specific latent heat of fusion, we use the formula energy required is equal to mass multiplied by the specific latent heat of fusion. Make sure to check the units. Mass is given in kilograms, which is the standard unit. Specific latent heat is given in joules per kilogram, which is also standard. Plugging in the given values, we get that the energy required is equal to 2 kilograms multiplied by 334,000 joules per kilogram, which equals 668,000 joules. So the energy required to melt the 2 kilograms of ice is 668,000 joules. Don't forget to double-check your units. In conclusion, the formula E equals ml helps us to calculate the energy required to change the state of a substance. Masses, m, is measured in kilograms, and specific latent heat, L, is measured in joules per kilogram. The energy required, E, is measured in joules, J. In our example, we calculated the energy needed to melt 2 kilograms of ice using the specific latent heat of fusion. By understanding and applying the formula E equals ml, we are better equipped to quantify the energy involved in state changes and understand the specific conditions required for these transformations.